AP Calculus, AB, Indefinite Integration, Trig Functions, Part C. I said that I was going to try to find a couple that were more difficult, and one of them that I found just looks really difficult. So I'm going to share that with you at an event in my class where students were doing this problem, and it was so easy, and I took it down the wrong road, and they just watched me crash and burn. So if you're one of those people and you're listening right now, I'll get even. Okay. So what I did, the mistake that I made here was that I complicated this whole issue. I forgot. I remembered that I should rewrite, and that's a good thing. What I did that was poor was that I overthought this. What I should have reminded myself is that I was trying to get to something that looked like an integration formula that I already had. So as I looked, I should have realized that there is an integration formula that handles secant x tan x. And there's also one for secant squared x. So what I should have done was that I should have thought my way through that a lot better. So if you're still laughing, that's great. So what I should have done is this. I just should have distributed this to here and here. Okay? I would have stayed inside integration. And would have looked like this. This times this would be secant x tan x, isn't it? Minus secant squared x all dx. Right? And from here, I mean, you may be surprised, but if you go to your integration formulas and look, you'll see clearly that secant x tan x integrates to secant x plus c. So I can just start integrating here. Right? I can just start integrating. Just give you a note that says I'm going to integrate. I'm going to drop the integral, and I'm just going to start taking that. So secant x tan x is the same as secant x plus c. This negative sign right here is this one. We know that secant squared x has an integration formula of tan x plus c. So tan x plus c, and we have this thing done, don't we? Now, this is a weird thing, and I want to talk about it a little bit. But if you look at this, this would be secant x minus tan x plus c, which is 2c. And my argument to you is that 2c is irrelevant because it's just a constant. It doesn't matter what that constant is, because if we differentiated, no matter what the value of this constant is, the derivative of a constant is 0, right? So, and how could I prove that? I could prove this by differentiation. If I differentiate backwards, I should get right to here, shouldn't I? And we would. All right? I have one more that I wanted to share with you. I think there's just one more I really wanted to share with you. I think there's one more, isn't there? There is. And this is the same thing. This is just going back to trig a little bit, but I think it's really reasonable if you think about it. I think sometimes the hardest thing to do is know what to do or where to look or how to see the problem. So this one is cosine x over 1 minus cosine squared x dx. So I look at that and I'm like, I don't know what I'm going to do with this, and I don't know what I'm going to do with it. So what I ended up doing with it is I just tried to pay attention and ask myself, well, what do I know about this? Are there any replacement values here, which took us back to trig? And given the Pythagorean theorems, right? We have Pythagorean IDs, right? And if I'm confusing you right now, I just would really encourage you to go back and look this up, because once you see it, you're like, that's it, and it is it. I'm seeing this piece right here. And I'm realizing that it has a Pythagorean identity that's going to really help me. So if you don't mind, I'm going to just rewrite this problem. So there's our integral. Here's cosine x. And what I'm saying to you is this, that I know that this has a replacement piece. And if you look at the Pythagorean identities, we know that cosine squared x plus sine squared x is equal to 1. So check this out. If I just move this piece over here and subtract cosine squared x from both sides, I get that sine squared x is equal to 1 minus cosine squared x. So sine squared x is this value. So I'm just going to take, I'm just like, you know what, here's my sine squared x. And you may not be thrilled yet, but hopefully you will be in a second, because I'm going to rewrite one more time. And I'm going to rewrite like this. I'm going to say, you know what, this is the same as cosine x, isn't it? Sine squared x is sine x times sine x. This is a multiplication sign here. Okay? So now I can just partition this out and say, oh, these all should have the x's at the end, shouldn't they? Sorry. Somebody was going to think about writing me a letter. So what I'm going to do now is this. I'm just going to rewrite one more time, and hopefully you'll be able to see this. Get cosine x over sine x times 1 over sine x. Well, what is cosine over sine? This is all the x. What is cosine over sine? Go back to your trig. This is a trig ID. And we know that cosine x over sine x is cotan x. So we have cotan x times 1 over sine is cosecant x. Right? The x. From here, we can integrate, because if you look, there is a formula that covers that, right? And it suggests to us that when we integrate this, and I'm just using this formulaically, when we integrate this, we're going to get opposite cosine x plus c. So there's your answer. All right? So I really do. Whoa, whoa, whoa. It looks like the railroad here. Sorry, yeah. Cosecant x. All right? And this is an opposite sign. So I hope that was helpful. Remember, just to make sure that you're doing your rewrites and that you're rewriting with the expectation that you're going to match your rewrite to a formula. So as you're starting to rewrite, you should be saying to yourself, what formula does this look like? And that's the way to get to it, all right? Great work, you guys. Comment. I'm dying to hear from you.